Now, doesn't that imply that y of t, because t equals x minus 1, I am simple country folk, you guys know this, is x minus 1 thirds plus 2. Not enough information. I need a little more than this. I'm going to call this tangent of x minus 1 over 3 plus 6 over 3. Right? Ooh, I'm going to need a little room for some algebra here. Sorry, you guys. Which implies that y of t, now that feels funny because y of t equals something with an x in it. But remember, t just equals x minus 1 over 3. All right? I know that's a little ugly, but bear with me. So tangent of, this is going to be x plus 5 thirds, which could be written as, here you go, the big crescendo. Let's do this in an obnoxious color. That y of t is equal to the tangent of 1/3 times x plus 5. Now, think about what goes on there. What's happening here? That changes the period from pi to 3 pi, and this is a horizontal shift left of 5, right? All right, now let's see how that plays out with our calculator. So, ooh, look at that. That's in perfect position. So what did I say that x of t was? I know that x of t is parenthesis x minus 1, whoops, minus 1. Wait, what am I doing? I apologize. Clear. We already know what this thing looks like. What I need to do is I need to go to my mode, and I'm going to put it back in function, right? And hit enter. And then I'm going to go back to y equals, and I'm going to clear that out. And I'm going to go y of t is equal to the tangent of parenthesis 1/3, 1 divided by 3, and then another paren, and I'm going to go x plus 5, is that it? X plus 5, and it better give me the same function. Let's see. Enter. Let's see. Waiting. Now, this looks a little goofy, but look, if I tweak my window and I go from negative 2 pi to 2 pi, let's see if I end up with the same looking function. Now, careful. Remember, this window right here is on x. This is my x and my y value. Now I'm going to pop back and forth, and it may drive you crazy, but this is one of those things where you got to pay attention to your window, or you're going to get information that can be a little bit confusing. Watch. When I'm in parametric mode, all right, and I hit enter, and I go back here, and I let x be 3t plus 1, 3t plus 1, and then I let y be the tangent of t plus 2. I don't know why that got erased. I must have hit a crazy button. In paren. Watch what happens here. Perfect. It's beautiful. Now, notice it threw in this right here. That's kind of ugly. Again, one more time. Go back to mode. Go down to function. And look, I get exactly the same thing. That's pretty cool to play with. I forget how to, one of you guys is going to have to show me how to turn off vertical asymptotes. All right, so enough of that business. Let's get back to this guy. For some reason, when I open the screen up large, the bamboo tablet, it's giving me that weird lag with the pluses. Maybe we can figure it out why it's doing that. And it doesn't do it when it's only working with the halvesy. Now, watch this. Let's find the equation of a circle. I got to get off of red first because I'll drive you guys and myself crazy. Watch this. What do you think if x of t equals, say, 3 cosine of t, and y of t equals 3 sine of t? Now, this should harken back to our understanding of polars, all right? But it's going to change a little bit. Watch what happens. What do you think happens? If I had to, I'm not going to force you guys to do this. You'll kill me. I could do one of these coordinate shrubs if I wanted to, and I could plug t equals 0 and t equals pi fourths, etc., etc. Right? I'm not gonna. What I'm going to do is I'm going to plug it into my handy-dandy calculator, and I'm going to show you what happens. So I got to change from function to parametric. And I'm going to clear this guy out. And what I say, 3 cos t, and 3 sine t. 3, whoa, look at that. That thing's crazy. How cool is that? And, sorry, math is fun. Sine of t, and then delete, and hit enter and watch this. Bam. Now, this looks a little crazy, but it's because my square, look, if I go out 1, 2, 3, and I go up 1, 2, 3. So remember how to do this one? I go to zoom square and watch what it does to it. Yeah, it carves it out. I'm going to do that again. All right? I'm going to go, did you see what happened? I started at 3, 0. I went up to 0, 3. I went to -3, 0, down to 0, -3, and then back around. So I started here and I opened up counterclockwise. You see how that kind of works? Pardon me. Now, what happens, since direction appears to be important, if I pop over here, direction appears to be important. Now look at that, no lag. It's crazy. I started here. This was t equals 0. We could double check it. When t is 0, cosine is 3, and sine is 0, right? And then I went this way until I carved the whole thing out. You see how important that is? Because if we're following the path of an ant across a coffee table, I need to know the direction it's moving. If the ant does a perfect circle, I don't know where it started and where it stopped. So, excuse me, what I'm going to do is I'm going to move this. I'm going to see what happens. What if instead of x of t equals 3 cos t and y of t equals 3 sine t, what if I flip them? X of t, I'm going to make 3 sine of t, and y of t, now look at that, no lag, equals 3 cos of t. What do you think is going to happen? Well, when t equals 0, x equals 0, y equals 3. What happens when t equals pi halves? Well, x equals 3 and y equals 0, doesn't it? So what appears to be happening is, for this guy, I start at 0, 3, and I go clockwise. Well, don't believe me, throw it in your calculator. See what happens. So if I want to go over here, and I'm going to stick a sine in there, and then if I want to go over here, and I'm going to stick a cos in here. Now watch what happens when I graph it. The one bad thing about this is it doesn't show you direction, it just shows you a curve. But watch when I graph it. Watch. Okay. Ooh, that went really fast. See? Booyah. See how that carved that out clockwise and it started at 0, 3. Now think about this. What would happen if I wanted to carve it out counterclockwise, but I still wanted to start it at 0, 3? What would I do? What would I do? That's easy. I would simply make the y, or excuse me, make the x, whoops, negative. Watch. Watch this. Back here, y. I'm going to insert, I think that would do it. Let's check. I'm going to insert a negative. It's always fun to explore, right? I'm going to hit enter. Notice the graph of it is still the same. Nothing changed. But when I graph it here, watch what happens. Yeah, that's what I'm talking about. 0, 3. But it carved it out in the counterclockwise direction. We're going to play with those a whole bunch. Those are actually really fun to do. Now, I want to emphasize something. Watch what happens if I change my t-step from 0.13 to 1. All right? And I hit enter. Watch what it does. See, look at that. You can already see it. Now, the reason is that the t-step, oh, God, that's awful, isn't it? When in doubt, go back to zoom standard. In other words, reset all your business and then tweak your zoom to a zoom box to make it pretty. Okay? All right. Now, algebraically, why is this a circle? This is really important because they just kind of threw it out there. So easy. Watch this. I know that if x of t equals 3 cosine of t and y of t equals 3 sine of t, doesn't really matter, and I'll show you why in just a sec. Do you guys agree that x thirds is equal to cosine of t and y thirds is equal to sine of t? You agree with that? Well, if that's true, Why can't I square everything? I can. There's no law that says that I can't. I'm going to have to come back over here. Let's do a new page. So what did I say? X thirds equals cos t. Y thirds equals sine of t. Doesn't that imply, after I've squared everything, that x squared ninths plus or equals cos squared t and y squared ninths equals sine squared t? Now, what's begging to happen? I got a sine squared, I got a cos squared. Add them. X squared ninths plus y squared ninths equals what? 1. Multiply 3 by 9. X squared plus y squared equals 9. Oh. Which, guess what, is a circle centered at the origin with a radius of 3. Now, we're going to play with this in class. I'm going to give you a fun little extra credit problem to do. But if I want to move this circle left or right, because remember, the whole thing started with x of t equals 3 cos t, and y of t equals 3 sine of t. What would happen, what should I do if I want to move the x up 1 or up 7? Think about that. How would I do that? It's so easy. That's what's so cool about parametrics. Watch. If I just want to move the whole circle up 7, would this do it? No, that would move it right 7. But what the heck? Let's move it right 7 and up 7. Nah, let's not move it up. Yeah, what the heck? Let's go 3 cos of t plus 7. All right, now let's see if we can play with this. If I click back over here, I go, why? And I'm going to cruise over here. Now I got, I want to get rid of that negative, don't I? Whoops, I'm a mess. Delete. I need to close a paren. In paren plus 7. And then watch, you're already going to see it move right down here. Watch. Doink, over it goes. And then let's move it up 7 plus 7. It's a wonderful application of parametrics. It's really, really simple to move stuff around. Look at it. Now let's graph it. Here you go. Math is so fun. Now, what if I wanted to move it right 7 and down 2? Well, it's easy. I know this drives you crazy, right? Down 2 would just be subtracting 2 from all the y values, right? So, whoop, and minus 2. And graph. Here we go. So cool. Really, really fun. All right. Well, that's enough of that business. Let's see what happens if we start tweaking this guy. You know what? I'm going to leave this here just because it runs so smoothly rather than making it big. What do you think? It was really easy to prove algebraically why this guy turned into this guy. Nothing to it. As long as the coefficients of the sine and the cos are exactly the same, I'm going to get a circle. What do you think happens if I let, say, x of t equal 4 cos t and y of t equal 2, sine t? What do you think is going to happen? Well, look close. Don't even look close. Let's graph it. Y of t. Let's get rid of that. Whoops. I want to get rid of that. Go away. Clear. And clear. What did I say? X of t is 4 cos. 4 cos t